Hey guys, hope you're well. Here we have grade 12 maths, November 2019. It's a paper 1 exam, 150 marks, 3 hours long. If you want to download the paper, just check the description below. Question 1.1.1 is a very easy question which you might be tempted to try and factorize this one by using the double brackets. And for this particular example, that technique would work. If, however, you have forgotten how to factorize, I know a lot of grade 12 students, they don't really know how to factorize that well anymore, then what you can do is use the quadratic formula, which I've put on the screen now. And I'm sure by now you guys know how to use that formula, so I'm not going to go and waste time inputting all the values. You know how to do that, right? And so if you did use the formula, you would get x is equal to 1 or x is equal to negative 6. If you did the factorizing method instead, which some students still do, it would be x minus 1 and x plus 6. And then you would end up with x is equal to, that's positive 1, or x is equal to negative 6. Question 1.1.2, guys, when they say correct to 2 decimal places, that is a clear indication that you need to be using the quadratic formula, because you cannot factorize something and get decimal places as your answer. So we're going to jump right into the quadratic formula. Now, I know for a fact that you guys know how to use this formula by now, but I'll just quickly let you know that the value of A would be 4, the value of B would be 3, and the value of C would be negative 5. All you do is you then plug those values into the equation. If you do this correctly, you should get an answer of negative 1,55 or x equals to 0,80. Moving on to question 1.1.3. So there are multiple ways to do this question. One of them would be to realize that this here on the left is a difference of square, and I know a lot of grade 12s do struggle with that, but if you do, you could say 2x minus 1 and then 2x plus 1. Okay, so that's difference of squares, and then you would solve for x. And if you had to solve this one for x, so if on the side here we just say 2x minus 1 equals to 0, you would say 2x is equal to 1 and x is equal to a half. And then if you had to do this one, you could say that 2x plus 1 is equal to 0, 2x is equal to minus 1, and so x is equal to negative a half. Now guys, because we have an inequality, those are not your answers. Okay? What you do is you draw a little number line and you put those values on your number line. This is very important. This is where a lot of students get confused. What I like to then do, and it works quite nicely, is I look at this original question and I ask myself, what type of graph is that? Well, that is a parabola, right? Because it's got the x squared. And because the x squared is positive, it means the parabola is facing in this direction. If the number in front of the x squared was negative, then it would go downwards. And so you could imagine that we've already found the x-intercepts of this graph. It would be a negative a half and a half. So I'm going to draw a happy parabola, or I call it a happy parabola because you can see that it's smiling. And then all that I do is I look at this equation and I look at it carefully. It says that where is this parabola smaller than 0? So it's saying, where is the parabola negative? Now, guys, they're not talking about negative as in these numbers. What they mean mathematically is, where is this parabola beneath the x-axis? So this part here would be where it is negative, and this part and this part is where it is positive. So I sometimes like to think of this over here as the ocean. Okay, you know the ocean where you swim, and everything beneath the ocean is negative, and everything above the ocean is positive. Okay? So they want to know, where is this graph negative? So where is this graph under or beneath the ocean? So it's beneath the ocean over here. Now, how do you answer that in a test? How do you tell your teacher that it's over there? Well, what you do is you say that the x values, because these are x values, should be bigger than negative a half, but they should also be smaller than a half. And they don't have a smaller than and equal to sign, so I'm not going to include the half and the negative a half. If you answer this in a different method, you might use interval notation. Then you would say x is an element going from -1/2 up to +1/2. I'm using round brackets, not square brackets, because I'm not including those values. This is question 1.1.4. It looks extremely intimidating at first, but let's see what we can do with this one. So the first thing I would do is I would multiply these two brackets together. Now what you should know is that when you multiply two square roots together, for example, square root 3 multiplied by square root 2 gives you square root 6. If you're a little bit confused right now, let me prove this to you. What if I said the square root of 4 times by the square root of 4? Some of you are quite comfortable to tell me that the answer is 4. But let me show you why that is. Because if we stick to my rule and say that you should multiply these two values, you would end up with the square root of 16, and the square root of 16 is 4. So in summary, when you have two square roots multiplied by each other, the answer is just the two numbers multiplied together. And so if I multiply these two big square roots together, then the answer, well, actually let me just write this a little bit bigger. I want to make sure that you guys get this. And so what's going to happen is that this square root on the left and this square root on the right, they're going to multiply together and they're going to become one big square root. So I'm going to make it one big square root, and everything else on the inside is going to stay as it is. Don't worry too much about the square roots that we can see there. And then square root of 32 minus x equals 2x. What I would then do is I would multiply these two brackets out on the inside. But there's various ways. What you might have thought of doing, and it's absolutely fine, I think I might actually do that, I think it'll be better, is let's try get rid of this square root over here. How could we do that? Well done if you said we could square both sides. Because in maths, if you can do pretty much anything as long as you do it on both sides. So I'm going to square this side, and I'm going to square this side. Now what this 2 does over here is it completely erases the square root, but everything else stays the same. And so what we have now is the square root of 32 plus x, and that's all going to be equal to x squared. Now, you didn't have to do it like that. You could have first multiplied the two brackets out and then squared. It doesn't really matter in maths as long as you don't break any of the main rules. So what I'm now going to do is I'm going to multiply these two brackets together. And so I'm going to start off with the square root of 32 multiplied by the square root of 32. Now, of course, in the test you could just use your calculator, but if you remember what I said that the square root of a number times the square root of the same number just becomes that number. If what I just said is completely going over your head, just multiply them together on your calculator and you will get 32. I'm then going to multiply those, and that's going to give me minus x square root 32. Then I'm going to multiply these two, and that's going to give me x square root 32. And then lastly, those two. So that's going to be negative x squared is equal to x squared. What now happens, and this is awesome, it's going to make our life very easy, is that this part and this part cancel out because the one is a negative and the one is a positive, so they can be crossed out. Then what I'm going to do is I'm going to take this negative x squared over to the right hand side, and that's going to give me 32 equals to 2x to the power of 2. I'm then going to divide by 2, and so that's going to give me x squared is equal to 16. And now there's multiple ways to go from here. What some students would do is you would take the 16 over to the left, where you would realize that this is a difference of squares, and you would factorize that as x minus 4 and x plus 4 is equal to 0. Then your two answers would be x is equal to 4 or x is equal to negative 4. Other students, in fact most students, at this step would take the square root and you would end up with 4. But the risky part about doing this method is that very often you might forget to say plus and minus. Remember that, guys, when you take a square root, the answer is plus and minus. So the square root of 16 is 4, so then you should say x is equal to plus and minus 4. Now something that some area where a lot of students forget, and it doesn't really matter to be honest, because you'll only lose maybe 1 mark if you forget to do this point or this step. But when you have a question that has a square root in it, always take your answer and check it. Make sure that it works. So, for example, the way that you would check it is you would take your first answer, which is x is equal to 4, and you would plug that into all the places where there is an x. And I would only plug it into the left-hand side for now. And so you could actually say here left-hand side if you wanted to. I would then go type all of this on my calculator. And that gives me an answer of 4. I would then go plug x into the right-hand side, which is literally just x. So that means that's going to be 4. And therefore everything looks good because the left-hand side is the right-hand side. And that's good. I would then do the same process using negative 4. And so that would become negative 4. Be careful over here because there's already a negative and your number is a negative 4. It's actually going to turn into positive 4. I would then type all of this on the calculator and that's going to give me 4. I would then have a look at the right hand side, which is just the negative 4. And so have a look at this. The left hand side and the right hand side are not equal to each other. And so therefore x can only be equal to 4. So moving on, in this question we have a simultaneous equation. Now, simultaneous equations, you should get full marks every single time. I have hardly ever seen a difficult simultaneous equation. You just have to follow a couple of basic steps. So, a nice way to do this is to do the following. You could call this equation number 1, for example, and you could call this equation number 2. What you then do is you look at both of those equations and you choose the one that looks very simple, a very easy one. So definitely that's going to be number 1. You then try and get either the x or the y by itself. It doesn't matter which one you do. And so I'm going to take this equation and I'm going to get x by itself. Okay, so that means that x would be equal to 12 minus y, and I'm going to call this number 3. What you then do is you take this equation and you plug this inside equation number 2. So what do you mean by that, Kevin? Well, what I mean by that is the following. It says here that x is equal to 12 minus y. So then I can take that and I can go to the other equation, and wherever I see an x, I can replace that with 12 minus y. Because it says here that x is the same as 12 minus y. So I replace it. And so you could say something like, substitute number 3 in to number 1. And so I'm going to write out equation number 2, but wherever I see a x, I'm going to put a bracket. Can you see that? Wherever I saw an x, I used a bracket. I'm now going to put 12 minus y inside there. And so have a look at this, guys. We've taken an equation that had a mixture of x's and y's, and now this equation only has y's, and so we can easily solve this. So I'm just going to multiply everything out, and so that's going to be 12 times y, which is 12y, minus y squared, equals to 14 minus 36 plus 3y. It looks like this is going to turn into a trinomial, because I can see some y's, I can see some normal numbers, and I can see a y to the power of 2. And so you could take everything to the left, or you could take it to the right. I'm going to take everything to the right. And so that's going to end up with 0 on the left, y squared on the right hand side, minus 9y. I'm jumping a few steps ahead here. What I did was I took 3y minus 12y. And then for the numbers over here, it's going to end up being minus 22. And so now we have options. You can always try factorize if you want. This one over here, if I look at it quickly, this one will factorize. But I do know that a lot of grade 12s, you don't really like to factorize, because ever since grade 11, when you learned the quadratic formula, you use that. And that's absolutely fine. That I would do the same, to be honest. So if you had to go factorize this, your brackets would end up being the following: y minus 11 and y plus 2. And so if you had to solve, you would get that y is equal to 11 or y is equal to negative 2. Of course, if you used the quadratic formula, you would get the same answers. So guys, don't stop there. We've only found y. The goal of a simultaneous equation is to find x and y. So let's start with y equals to 11. So what you're going to do now is you need to find the x value when y is equal to 11. So the best equation to use is to come back to number 3. So number 3 says that x is equal to 12 minus y, and so I'm going to plug in 11 over there, and that's going to mean that x is equal to 1. So therefore, when x is 1, then y is 11. That is your first point. X is 1, y is 11. Then I need to see what happens when y is 2. And so I'm going to use this equation over here again. And so I'm going to say x is equal to 12 minus. Now, because there's a minus over here and there's a minus over here, you should be careful. So I'm just going to use a bracket. And that's going to end up giving me x is equal to 12 plus 2, so x is 14. So therefore, when x is 14, then y is minus 2. So your answer is this one over here and this one over here. With number 1.3, this is quite an interesting looking question, and if you find yourself struggling with this one, I wouldn't really stress. In every type of exam, they're always going to throw in a weird question like this, and it's not really something that you can prepare for. I would rather you focus on the questions that are very common, such as calculus, series and sequences, graphs. Whereas these types of questions, you might know how to do this one, and you might learn how to do it, but then in a different exam, they're going to give you a totally different kind of question. So don't let this question bother you, but let's quickly have a look and see how we could do this one. So what I would do is, if something is a factor, it means that it can divide into a number. Now, a number 3, like 3 to the power of 1, which is 3, or 3 to the power of 2, which is 9, or 3 to the power of 3, which is 27, this type of number will only be able to divide into a multiple of 3. It won't be able to divide into 4 or 5. It will only be able to divide into multiples of 3. And so what I would do is I would isolate all the multiples of 3. So that would be 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Now, I would then rewrite them in terms of 3. So 6 is the same as 2 times 3. 9 is the same as 3 times 3. 12 is the same as 3 times 4. 15 is 5 times 3. 18 is the same as 6 times 3. But now be careful, because 6 is 2 times 3. So I'd rather write it like that. I'd rather say 2 times 3 times 3. 21 is the same as 7 times 3. 24, 8 times 3. 27 is the same as 3 times 3 times 3. You might have said 3 times 9, but then 9 is the same as 3 times 3. And then 30 is the same as 3 times 10. So, what I would then do is add up all the 3s. So there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I could divide by at most 14 3s. Because remember, if something is a factor, it means you can divide by it. So you can imagine me dividing by 3 to the power of 14. Well, 3 to the power of 14 is the same as 3 times 3 times 3, 14 times. And so that would look like this. And so if you had to do that, you can see that this 3 would cancel with that one. This one would cancel there. This and this would cancel there. This would cancel there. This one would go there. That would go there. That would go there. And you can see what's happening, hey guys? So this is the approach I would use. But as I said, don't let this question worry you. Okay, why is it not cancelling perfectly? It does work. And there we go. So, and then if I had to add another 3, so like 3 to the power of 15, then all of a sudden there would be nothing that could cancel out this 3. And so it wouldn't work. So the maximum number would be 3 to the power of 14. I hope that makes sense. And so it says here in question 2.1.1, write down the value of the next 2 terms of the sequence. Well, let me first write these numbers down so that we can try to see what's happening here. So we need to try and see what the difference is. So to go from 321 to 290, you would have to minus 31. And then it's minus 29, minus 27. To work out that difference, you always take the number to the right minus the number to the left. Then if I go one row down, I can see that that would be positive 2. So I said what I did is I said minus 29 minus 31, and that gives me positive 2. And then over here it would be positive 2. So remember, a quadratic number pattern stays constant in the second row. And so I can then add another 2 over here, which would make this minus 25. And so 234 minus 25 would give you 209. And then if I just keep going on with the pattern, this would be minus 23. And so 209 minus 23 would be 186. So the next 2 terms would be 209 and 186. So moving on to question 2.1.2, they want you to determine the general term of the sequence in the form an squared plus bn plus c. So guys, this is easy marks. What you do is there's this special way we can do this. You write out the following formulas. Now, not all schools do this method, but most schools do. You need to memorize these three equations that I've just written down. You then circle the first of each row like that, and then you solve. So you start at the bottom, and it starts by saying that 2a is equal to 2, and so a would equal to 1. Then we move to the second row where it says that 3a plus b is equal to minus 31, but a we already have, and so that's going to be 3 times 1 plus b is equal to negative 31, and if you go work this out, b would be negative 34. And then if you want to get c, you would just use the very top formula, which says that a plus b plus c must equal to 321. But we already have a and b, so a is 1, b is negative 34, plus c is equal to 321. If you go solve this, you would find that c is equal to 354. Where do these three formulas come from? Those were mathematically determined many years ago. You can always use them. They always work for quadratic number patterns. Moving on to question 2.1.3. Oh, but I haven't actually written down this answer. So it was Tn is equal to n squared minus 34n plus 354. So it says here for 2.1.3, which term or terms of the sequence will have a value of 74? So what I do is I write down my formula. And what you must remember is that n is the position or the specific term, and then Tn is the value. So for example, this 290, that would be the value, and this would be at position number 2. So n would equal 2. So what are they giving us here? They're telling us we'll have a value of 74. So I fill that in over here, 74. And then I solve. So this is definitely going to be a quadratic. So I take the 74 over to the left-hand side. So it's n squared minus 3n plus 280. Because I said 354 minus 74. I would definitely use the quadratic formula over here. Oh, and I see that I forgot a value over here. That's supposed to be 34n and 34n. And if you do that, you get n is equal to 20 or n is equal to 14, and so we give both answers, and this is why they said term or terms. 2.1.4, very, very good question. Which term in the sequence has the least value? Well, there are multiple ways that you could handle this question. One of them is to realize that if this was a graph, what type of graph would it be? Well, it would be a parabola, so it would have a shape like this. How do I know that it looks like that? Because the number in the front of the n squared is positive, so it's a smiling parabola, it's facing upwards. And if you wanted to find the term that has the least value, that would be to find this point over here, and so that would be finding the turning point. And so we know that for a parabola, to find the turning point, it's minus b over 2a. If you forget about that sometimes, it's over here, minus b over 2a. And so that would be minus 34 over 2 times 1, and that's going to give you 17. Therefore, it will be term 17. The other way to do it is to use calculus. We know that for calculus, to find the maximum or minimum point, for example, turning point, how do you do that? Maybe pause the video and ask yourself, how do you find turning points? You take the first derivative and you make it equal to 0. And so let's do that. If we take the first derivatives, that'll be Tn, it'll be 2n minus 34, and we make the first derivative equal to 0, and that's going to end up giving you 2n is equal to 34, and so n is going to be 34 divided by 2, and so that's going to be 17. So term 17 will have the lowest value. It says here, given the geometric series, so the geometric series is the one that uses r. And they tell us that it's a series, so they're adding everything together, and then that all equals to k. So what it means is that if they add up all of these terms, the answer is k. It says determine the value of k if the series has 21 terms. Well, we know that a geometric series can be calculated using the following formula, where a is always term 1, r is the ratio, and n is the number of terms. And so what I can do is I can say that Sn is equal to the first term, which is 5 over 8. To work out r, you take term 2 divided by term 1. And that's going to be 5 over 16 divided by 5 over 8. And you can just type it in on your calculator like that. And that gives us a half. So it's going to be a half to the power of 21, because I said there's 21 terms, over the ratio, which is a half, minus 1. Go ahead, type it in on the calculator just like that. And if you round that to 2 decimal places, it's going to give you 1,25. Then it says determine the largest value of n for which Tn is bigger than that. So what I like to do, they're saying that Tn, so I'm going to go find Tn. So I know that for a geometric pattern, Tn is the following. And so Tn for this pattern will be A, which is 5 over 8. The r value is a half, and n I don't know. They just want us to find, n, so I'm just going to do that. So this is Tn, so I can now put that in the place of Tn. And so that's going to be 5 over 8 times by a half to the n minus 1, then that symbol, 5 over 8, 1, 9, 2. What a lot of students do now is they multiply these two numbers together. But guys, you can't. The reason is that there are exponents over here. So what you can do, though, is realize that this 5 over 8 doesn't have any exponents, and so you can divide it. So you can end up with a half to the n minus 1 is bigger than 5 over 8, 1, 9, 2 divided by 5 over 8. Go ahead, type that in on the calculator. That will then give you a value of 1 over 1,024. What I would then do, well, you could even use logs here if you wanted to. Some students use logs. So if you do use logs, you'd say that n minus 1 is equal to log of a half and then 1 over 1024. After doing all of that, you would then take the minus 1 over. But another method you could use is you could realize that this is 2 to the power of negative 1, and 1024 is the same as 2 to the power of negative 10. How did I get that? Well, let me first get 1024. So what I do is I type in 1024 on my calculator. I then say equals. I then say shift. And then I say fact. This is on the Casio calculator, and it tells you that 1024 is the same as 2 to the power of 10. I then took the 2 to the power of 10 up to the top. Now I need to multiply these together, so that becomes 2 to the negative n plus 1. What now happens is that you've got 2's on both sides, and so you cancel those. And so you're now left with minus n plus 1 is greater than minus 10. Now there's multiple ways to carry on from here, but I would take the minus n over to the other side, and then you would end up with n is smaller than 11. And there is your final answer. Without using a calculator, determine the value of the following. Let me quickly just talk to you a little bit about what this actually means. So I'm just going to look at the first one. It's a sigma notation, which I know some of you don't like sigma notation. But let me show you what this actually means. What we'll do is, or the way that this works is, they start with this number here at the bottom, which is a 3. And you plug that number into this equation. Okay, so you plug that number in. There we go. Then you say plus. That is what sigma notation actually means. It means add all of the terms together. What you then do is you plug in the next number, which would be a 4. So you plug in a 4. Then you plug in the next number. And you keep going until you reach this number at the top. That is what sigma notation actually means, okay? So I'm just going to fast forward a little bit to whenever we would have used a 9, or let's use an 8, then a 9, and then eventually we would have used a 10. And I've skipped a few numbers in between. Okay, so that is what that means. Now, in another color, well, actually, first I want to just simplify these numbers. So that becomes 1 over 1 plus 1 over 2 plus 1 over 3 dot, probably a whole lot of other numbers, plus 1 over, in fact, I'll just put the other numbers there for you guys. It's not going to be that long. 1 over 4 plus 1 over 5. And then I'm carrying on 1 over 6, 1 over 7, plus 1 over 8. Okay, so that's what this part over here is. Now I'm going to do this part over here. So you just start with the 3, so it's 1 over 3 minus 1, plus 1 over 4 minus 1, 1 over 5 minus 1, 1 over 6 minus 1. And then I'm just going to simplify 1 over 2, 1 over 3, 1 over 4, 1 over 5, 6, 7, 8, and 9. Okay, now what they want us to do is they want us to take the top expression, which is the one in red, and they want us to subtract the green expression. Okay, so they want us to take this one minus this one. Now what you should identify is that the halves are going to cancel when you minus them. The thirds are going to cancel. The fourths, the fifths, the sixths, the sevenths, and the eighths. And so this always happens. I've seen so many questions like this. You're always going to be left with the first number and the last number. It's usually like that. And so you literally now are just going to subtract those two from each other. And so therefore your answer is just going to be 1 minus 1 over 9. And so that's going to be 8 over 9. Okay, and that's how those questions usually work. Let's read. A steel pavilion at a sports ground comprises a series of 12 steps. Ah, Sage, awesome. A series of 12 steps, of which the first 3 are shown in the diagram below. Each step is 5 meters wide. Each step has a rise. Okay, so the height of each step is a third, or 1 over 3 meters. Nice, Aisha. And has a tread of 2/3 or 2 over 3 meters. Okay, so the tread is just this distance over here. So they tell us that that's going to be 2 over 3 the whole time. So this distance is always going to be 2 over 3. And then this little height is always going to be a third. They're telling us that that will continue forever and ever and ever, or for the 12 steps. It says the open side, which is shaded on the sketch. That's this part here, guys. This is the open side that they are talking about. They're saying that that open side is covered with a metal sheeting. Calculate the area of the metal sheeting needed to cover both open sides. Now, I know some of you are probably wondering, what about at the back? At the back, are they talking about that? No, they're not talking about the back. They're only talking about this piece here and this part on the other side. We need to calculate the area of those two things. Okay, now we can obviously all agree that the area of those two are the same as each other. So we can just calculate the area of the one, and then we can just multiply our answer by 2 at the end. That's just going to make our life easier. Okay, so this question is actually not that bad, because if we look at the first step, area of first step is just going to be equal to a third, which is the height, this piece, multiplied by 2/3. And that's just going to give us 9 over, whoa, what's that? 2 over 9. There we go. Now, if we look at the area of the second step, it would just be double that, but let's just make sure. So area of second step would be equal to a third, sorry, 2/3. Would you agree with me that this will be 2/3? This height over here, 2/3, hey? So the area of the second step is going to be 2/3 times 2/3. Let's just make sure you understand where I got that. Let's choose a different color here. This height is 2/3, and this length is 2/3. Okay? And that would give us 4 over 9. And then let's just go one more. Area of third step. So now this height here would be 3/3, which is just 1. You know, 1 over 3 plus 1 over 3 plus 1 over 3 is just 1, multiplied by this length up here, which would now be 2/3. That just stays the same. And so that's just going to give us 2 over 3. Right, now we need to look at these three numbers and we need to really sit down and pray and hope that it forms some type of pattern. Because if it doesn't form a pattern, then we would have to do that 12 times. But they wouldn't do that to you guys. That's just silly. It's either going to be arithmetic or geometric. So let's quickly tell, or let's quickly try investigate. So to investigate if it is arithmetic, we need to see if the difference is constant. So we can say T2 minus T1, and let's see what that equals. That's 4 over 9 minus 2 over 9, which equals 2 over 9. Then we need to check if the difference stays constant. So I look at T3 minus T2, and that's 2 over 3 minus 4 over 9, and that gives us 2 over 9. So if the difference is remaining constant, then it is an arithmetic pattern. It's an arithmetic pattern. So, so what we can now do, let me just find some space here, is we don't have to go add up all 12 of them. We're trying to add up all of the different areas. So what is another name for add up? Oh, yes, it's the sum. We need to find the sum of all of these terms. So we're not going to use a TN formula because that doesn't give us the sum. That only gives us the specific terms. But that's not what we're interested in. We want to know what is the sum of all of those areas. And so we use the sum formula of an arithmetic pattern, which is this one here. And then it's pretty easy. We know that the number of terms will be the number of steps, which is 12. A is the area of the first step. So that is the 2 over 9 that we got. The number of terms is still 12. And the common difference between the areas was 2 over 9. That is what we worked out when we were trying to investigate. There we go. And so now you just go ahead and you type that all on the calculator, just like that. And that gives us 52 over 3. And then I must just multiply that answer by 2 because I also want the area of the other piece on the other side, which obviously looks exactly the same. And so if I do multiply that by 2 and I round off my answer, I get 34,67 meters squared. Below are the graphs of f and g. So we have a hyperbola and a parabola. Let's quickly highlight that. So here we've got graph f, which is the parabola, and then we've got g, which is a hyperbola. So there, come on, okay. F has a turning point at C and passes through the x-axis at 1, 0. D is the y-intercept, the vertical asymptote, Okay. First question for 1 mark. Here I've written the marks. I just wrote them out manually. Hope that's okay. So it says write down the value of P. So where is P? Oh, okay. So P is here. So let's quickly talk about this. So if we have g of x equals to a over x plus p, and then I'm going to show you the normal equation of a hyperbola, x plus p plus q. You could say minus over here. It doesn't really matter, to be honest. What we must understand, though, is that this part over here tells us whether the asymptote has moved left or right, okay? And then this part over here tells us whether the asymptote has moved up or down, because remember, a hyperbola has 2 asymptotes. If I draw a typical hyperbola, you might get something like this. See how it always has 2? Now, some of you are like, whoa, Kev, you just said there's 2, bro, but here I only see 1. I can only see this one over here. The reason is that this specific hyperbola doesn't have a plus or minus q part. Does that mean it doesn't have an asymptote over there? No, it does not mean that. It just means that it has not moved up or down, so the asymptote is actually
over here. It's the x-axis. Okay? Hyperbolas always have two asymptotes. You can even see it over here. You can see that the green graph is not going over that line. So there is still an asymptote. You can almost imagine that they just said +0 over here. Okay, so we can see from the graph that the asymptote, the vertical asymptote, is here. Normally, if it was the most basic hyperbola that you could ever imagine from like grade 10 days, then it would just look like this and like this. So your asymptote is normally the y-axis and the x-axis. But now it's here. So it's moved one place to the right. So when things move one place to the right, what would you want the equation to say at the bottom? Would you want it to say this, or would you want it to say this? Which one shows that it's moved one place to the right? Well, that would be this one. And so P would have to be -1. But now we must be a little bit careful, because sometimes they're not going to give you x plus p. Sometimes they're going to say x minus p. So how do we handle this? Well, we know that the answer has to have a x minus 1 at the bottom. We know that. It must say x minus 1, because we know that the asymptote has moved one place to the right. So this is what you want at the bottom. So if they give you a over x plus p, then we know that these two parts have to be equal. So you could even imagine yourself saying that this must be equal to this. Now you see how these x's would cancel, and so there we could see that p is -1. But if they rather decided to say that their base is going to be, or like they might decide that this is going to be their general part. Sometimes they do that. They'll put an x minus p instead of an x plus p. So then you must know that this and this still needs to be the same. So then you could make these two parts equal. The x's would still cancel, and then you're left with that. So in that type of scenario, p would be 1. So it also depends on what they give you over here, but you know that the answer must say x minus 1 at the bottom. That is a fixed thing based upon what we see on the graph. But as I mentioned, they can sometimes put a x plus p or a x minus p. They can just decide that. It doesn't really matter. Next question says, show that a is 3 and b is 2. Okay, so b is part of that equation, a is part of this equation. Let's go do a first, just like alphabetical vibes. Okay, so if we have g of x equals to a over, now we know p is -1, so we can fill it in like that. Now, for that equation that I've just written down, we know that this is actually just a y. So the way you must think of this is, if they want you to find a, then the only things we need to go find is a y and an x. So we just need to go find a point on that graph. So can we see a point on that graph? You see how it goes through point D. So from this one's equation, we can actually get that. Some of you are like, yeah, but Kev, we don't know what B is. It's not going to matter. Check this out. I know that this is a y-intercept. So I know that I can make x 0. So if I make x 0, 0 plus 0, then these parts fall away. And so y is -3. So I know, and if you know your graphs very well, you would know that that's your y-intercept. So we know that the coordinates there are 0, -3. Now that point is a point on both graphs. So we can also use that now over here. So we can use the y as -3 and the x as 0. And so we just end up with that. Then you take this and you multiply it up to the top there, and you end up with a as 3. So now we have a, so we can just fill that in. So now for the other equation, it's x squared plus bx minus 3. So there's only one unknown, and that is b. So we need to use a point on that graph. But using 0 minus 3 won't work, because we already have the information that we need from that. You could even go try, and you're just going to realize you're going to end up with something like -3 equals to -3, which is pretty annoying when that happens. I remember like sitting in a test when I was still really average at maths, like grade 10 or whatever. I was still getting like 40s, 50s. And I would often do that. I'd go plug in the same thing, and then I'd end up like doing this whole long thing in the test, thinking I'm getting somewhere. And then at the end, it's like -6 equals -6. And I'm just like, really? So let's go find another point. Well, we've got a point. They told us over here that that is a 1. So that's x, obviously, and y would be 0. So you plug in the 0 as y. You plug in the 1 as x. And there we go. So now we can just say that, and then we can just take the 3 minus 1 over. Well, it became +3 and then -1 when I took it over. And so b is 2. And so, it said show that A is 3, B is 2. Oh, lovely. So we know we're correct. And what's also really nice about that, guys, and you must take this advice, is that let's say you could not do question 4.2. But look at this. They're telling you what A is and they're telling you what B is. So you could then go and do the rest of the questions. And even though you may not have been able to do this one, you might find you have the knowledge to do at least some of the other ones. So if you can't get this, don't just skip the entire rest of question. You can now have or use these values and go do the rest of the question. Now, this next one says, calculate the coordinates of C. Where is C? Okay, C is a turning point. That's an easy one. 4 marks. That's crazy. Because it's a super easy question because we now know what B is. And even if you couldn't solve it in the first one, you can now have it. Now, we know that to find a turning point, I mean, if you're a grade 12, you can obviously use calculus if you want. But I'm just going to stick to the basics that we learned for grade 11 techniques. This is actually calculus. If I ever had to sit down and have a coffee with you, I could show you that. So, where are we? Oh yes. So we want to go find the the turning point, the x value of the turning point. So we can go x equals to minus b. So b is 2, and then a is, for this equation, a is 1. That could be confusing for some. They might be like, no, but a is 3. But remember, a is here. This a is this number over here. Okay, you got to understand your work. So minus 2 over 2, and so that's minus 1. Always make sure, does that make sense? Like if we got a positive value now, but c is clearly on the left of the y-axis, so it should have a negative turning point x value. Always double check yourself. You might have just forgotten to put a negative, for example. Okay, now how do we find this value? The y value. Well, if you have the x value, then to find the y value, you just plug it into the equation. And so this would give you 1. This would give you minus 2. This would give you minus 3. And so that is going to give us 1 minus 5, which is negative 4. It's a negative, makes sense. It makes sense that it's also lower down than minus 3. These are little quick checks you can always do for yourself to make sure that maybe you didn't put a bracket over here, for example. Okay, so if we just fill that in quickly, minus 1, minus 4. This question says, write down the range of f. Okay, so range is the y values. So you look at the smallest y value, which would be there. And if you look at the largest y value, well, it would actually just keep going all the way up to infinity. So if you use interval notation, you could say y is an element going from negative 4 up to infinity. If you want to use set builder notation, you could literally just say that y is bigger than or equal to negative 4. Okay, now determine the equation of the line through C, okay, that makes an angle of 45 degrees with the positive axis. Write down your answer in the form. Okay, that just sounds super fancy, but it's super easy. Check this out. We know that it goes through C, and we know that it makes a 45 degree angle. Now you need to have not a good idea, but a decent idea of what 45 degrees looks like with the x-axis, positive x-axis. So here's your positive x-axis. So we know that the line's going to go through there. Okay, well, I'm not saying it goes through 1 and 0, but it does that. Now they said that the angle that it makes is 45 degrees. So that's 45 degrees. Now, what I've always told you, tan, gradient, angle of inclination. Yeah, but Kev, bro, this is like paper 1, bro. That's like paper 2 knowledge. Yes, I understand that. But sometimes they are going to throw in little things like that. Nah, Kev, that's crazy, bro. Yes, see, bro. Nah, ways. Don't know why I always whip out this Joburg accent. Like, I've actually never lived in Joburg in my whole life. But I guess I've just seen the boys, the gym bros. So listen, it's going to be 45. Yeah, a lot of people think I come from Joburg. I've had that a lot. I'm from the Western Cape. So, 45 degrees. Well, I was actually born in a little town outside of Durban called Ladysmith. You get 2 Ladysmiths. You get one with an I and one with a Y. Mine's the one with the Y. The one just near Durban. I was actually born there. But then back in 2007, moved to the Western Cape. So, yeah. All right. So, they want us to determine the equation. Now, as I've said, tan, gradient, inclination. I want your mind to always link those three things together. What I mean is that if you have, inclination angle. So if you have the angle, you can get the gradient. And if you have the gradient, you can get the inclination angle using tan. So if we know that this is 45 degrees, then we can say tan 45. Now tan 45 is 1. That means that the gradient of this line is 1. So now I know that the equation of a straight line is mx plus c, but I've just worked out that the m is 1. Now to find c, it's easy. You need a point, you need any point on that line. Now the only point that we have on that line, that we know for a fact is on that line, is this one. You might say, yeah, but maybe it goes through here. Maybe it does, maybe it doesn't. We don't know. And you might say, yeah, but isn't it going through here? Maybe it does, maybe it doesn't. We don't know. But we do know that it goes through C. So we use that, okay? So we're going to say that the y is -4 and the x is -1. And if you had to solve this, we should eventually see that C is -3. So it does actually go through this point after all, but we never needed to know that. And so we can say then that y is equal to 1x, or you could just say x minus 3. Y equals to x minus 3. Okay, determine the equation. Okay, so we've done all of those. Now we need to do this one. Is the straight line, which we've determined in 4.5, also a tangent to f? Explain your answer. Okay, I'm going to show you two ways of doing this. A grade 11 method, which obviously if you're in grade 11, you're only looking at this method, or a grade 12 method. Now, if you're a grade 12 learner, obviously you can use the grade 11 method and the grade 12 method. Both are fine. So we're going to, let's just say here, or let's say I, because I'm one person, I will do both a grade 11 and grade 12 method for 4.6. This is just for the people who like fast forward and then suddenly they arrive at 4.6 halfway through it, and then hopefully this will just show them when like a grade 11 learner starts seeing grade 12 work, hopefully they get the memo. Okay, so is the straight line determined a tangent? Okay, so we'll start with the grade 11 method. Now the way that you do the grade 11 method, we know that if something is a tangent, it only touches, the two graphs only intersect in one place. Only intersect in one place. Okay? If it touches in two places, then it can't be a tangent. So, how do we do this? Well, we know from, to make two things, to find out where two graphs intersect each other, how do we do that? We make their equations equal, right? So we start with that. So we're going to make the straight line that we just found in the previous question equal to the equation of the parabola. What was b, guys? Oh, 2. Okay, so we made them equal. Now we're going to go solve. And see what we get. So I'm going to bring that x over, and I'm going to bring that 3 over. So this one became a plus 3, which is that one over there, and then 0. And now you end up with 1x, and then the 3's cancel. Okay, now to solve this, you don't take the x over and then divide by x. No, you take out a common factor. So we end up with x equals to 0, or x equals to -1. So because we're getting two different answers here, it means that the graph intersects at two different places. So therefore, it cannot be a tangent. Because if it was a tangent, what you would get is you would end up with something like this. Let me show you how it would look. If it was a tangent, you would get, how can I do this? You would end up with something like this. Yeah, like that. Now, if you had to go solve this, you would end up with x minus 5, and then when you solve for x, you would end up with x equals 5 and x equals 5. So you'd get two answers that are the same. If that happened, then it would be a tangent. Okay? Another way you could have done that as well is at this point over here, instead of solving for x, you could have used the nature of the roots, b squared minus 4ac. And we know that if you get an answer of 0 for b squared minus 4ac, then it means your roots are equal to each other. And that is the same type of thing. So that's another way you could have done it. Okay, so, and I also told you earlier that, when we found out that this is minus 3, then it means that that's the y-intercept, which means the graph looks like that. So we can see it's touching in two different places, and we can see that this x value is minus 1 and this x value is 0. And that's exactly what we got as our answers over here, remember? So it's not a tangent. Now I'm starting to see why it's only 2 marks, because we could have just used that. Anyways, this is still very good knowledge. Now, if you were a grade 12 learner, what you could do, now this is for grade 12s, is that we know if something is a tangent, then we know that the gradient of that tangent must be equal to the gradient of the graph, which we find using the first derivative, at the point of contact, let's say at contact point. Okay? So at the point of contact, where is the point of contact? Well, let's just use point C. Now, it can't be a tangent, because what is the gradient of the tangent? Well, that is 1. I'm calling it a tangent, but it's not actually a tangent. But anyways, we know that its gradient is 1, okay? And what is the gradient of the graph? Well, you could go work it out if you wanted to by taking the first derivative and then plugging in the x value. But you should also know that this is a turning point. They told us that. So what is the gradient at a turning point? It's 0. So the gradient of the parabola is 0 at that point. But the gradient of the tangent is 1. So it can't be a tangent, because if it was a tangent, then the gradients of both the line, the tangent, and the parabola, they would have to have been the same. So in that case, you would say gradient of tangent is 1, but the gradient of the graph is 0. Therefore, not a tangent. The function h is equal to f, and then they say m minus x plus q has only one intercept at x equals to 0. Determine the values of m and q. Okay, so pretty much they're telling us that h, which is a brand new graph, is equal to the graph of f, which is this yellow one, but they then do a few modifications. This part here is going to move the graph either left or right, so either that way or that way, and then this part's going to move the graph up or down. Now, they said that they're going to move it in such a way so that it only has one x-intercept when x is 0. So how can a parabola only have one x-intercept? Well, that is only if it either does, come on, Kev, that, so it only touches at one place, or for example, it does that. Then it can only have one x-intercept. Now they tell us that the x-intercept is at when x is 0, so that's here. So the graph's going to do something like that. How do we know it's not like that? Well, the original graph is a happy face graph, and all that they've done is moved it left or right and up and down. They didn't put like a negative in the front here, so they haven't flipped it over. So they want to know, how must we move that graph so that it looks like that? Very easy, because we know that this coordinate is minus 1, minus 4. That means to get this point to here, we're going to have to move the graph one place to the right and then 4 places up. So we know that this is going to be plus 4. So let's go fill that in so long. But now the problem is, and the thing I don't like, is that they've made this part here really weird. Normally that part there would be like x minus p, for example. So I don't like that at all. So, and to try fiddle with that, it's going to get weird. So what I'm also going to now try do, I'll actually show you something quite easy. If we say that h of x is equal to f of m minus x plus q, I can then take this equation, remembering that b was 2, and I could say that, I could say that h of x, and I'm now going to substitute into the graph of f. Wherever I see x, I'm going to replace it with this. So I'm just substituting like what they said, minus 3, and then they said that we can say plus q. But now we've worked out q as 4. I explained that to you over here. So we could say plus 4. Now these two together just becomes plus 1. Now the only unknown here is actually just m. So I just need to plug a point on this equation. Now we know that this graph of h has a turning point at 0, 0. So we can plug that in. The y is 0, and the x is also going to be 0. And so that would give us m take away 0 is just m, so that's m squared. This is just going to be m, so that's going to become 2m plus 1. All right, so this could factorize, or you could just use quadratic formula, but it factorizes like this. And so m is just going to be -1 for both of those. And so there we have the value of m, and we found q. So m is -1, and q is 4. Yeah, I don't like how they did that whole part there, so that's why I went this route instead of just visually looking at it, because then we could have easily filled that in. But yeah, so that's how I'd end that one. Sketched below is the graph of f, which is an exponential graph we can see. The point 416 lies on f. Determine the value of k. That's very easy. Because we have a point, we can just substitute it in. So we know that y is equal to k to the x. So we can now fill in y as 16 and x is 4. Here we can take the fourth root on both sides. And so on this side we have k. The fourth root of 16 is technically positive and -2. Because this is a even value, you're going to have positive and negative answers. However, they told us that k is bigger than 0. So k can't be negative, so therefore k must be 2. Graph G is obtained when you reflect graph f along the line y equals to x, which is this line over here, which is actually the inverse line. That's what inverses are. They are reflections across the line y equal to x. So you need to just understand, when they say reflecting a graph along that line, that means inverse. Determine the new equation. So now we're just going to go do an inverse type of thing. So we know that k is now 2. Now we know that with inverses, we switch x and y, and then we get y alone. So the base is 2, so we keep the base as 2. We know that the inverse of an exponential is a log, and so there we go. This next question says, sketch the graph of G. Okay, so graph G is obtained by reflecting. Okay, so graph G is this log graph that we just found. Indicate on your graph the coordinates of 2 points. Okay, very easy, because what we must realize, yes, you can go draw a log graph if you want, but we already have the original graph. Okay, and we know that when you take an inverse, the x's and y's switch around. So if we take the coordinates 4 and 16 and you switch those around, well, then that just becomes 16 and 4. And then if you take this coordinate, which is 0 for x, 1 for y, you switch that around, it becomes that. So we can just go plot those points now. But also, remember that an exponential graph, which is this one over here, has an asymptote. If you can't see the asymptote, then it's because it is on the x-axis itself. So that is your asymptote y equals to 0. So if you now flip that around, then that becomes x equals to 0, which is actually a vertical line that goes this way now. Okay, and so let's go plot these coordinates. So 16 and 4 would be somewhere way off to the right over here, so maybe over there. Well, it's actually going to be there, because we know that an inverse is a reflection across this y equals x line. So it'll probably be somewhere there. 16 and 4. And then 1, 0 would be here at, 1, 0. And then you just connect them. And there we go. Use your graph to determine the values for which this. Okay, now these are one of those questions where usually they put a little dot over here or over there. But it's that same kind of question where we make a table. So if we then take, so what we normally do is we take f of x and we take g of x, and we want to multiply them so that the answer is bigger than 0. That means positive. How do you make a positive when you multiply two things? Well, let's just quickly write here that. Well, if this one's a positive and this one's a positive, then that will be a positive. And if this one's negative and this one's negative, then that will still be positive. So now what I like to then do is I call this situation 1. Let's lower this one down a bit. And then that'll be situation number 2. So let's start with number 1. So we want to go find places where f of x is positive. So f of x, positive. So f of x being positive means above the x-axis. Well, it's positive. It's above the x-axis everywhere. Okay? So then we immediately know that this one's never going to work because f of x is never negative. Remember, negative means below the x-axis, positive means above the x-axis. Now, In that place where f of x is positive, which is everywhere, is there a place where this one is positive as well, where it's above the x-axis? Well, yes, that would be here, because there it's above the x-axis. So the answer then is going to be from, or it's the overlap part, so it's this whole area here. So we always give our x values when giving the answer, so it's from this point, which is x equals to 1, all the way to infinity. Now, they haven't included 0, so we'll just say x greater than 1. If you want to use interval notation, you could say x is an element going from 1 to infinity. This next question says, where is g of x, which is the log graph, this one over here, where is that smaller than -1? So that's a y value of -1. So a y value of -1 is probably somewhere over here. Okay, so they want to know, where is it smaller than that? So where is it under that? So that would be this area here. Okay, now the thing is, we don't know the x value where that starts. We don't know this x value. So what we do is we take the equation of that graph and we say to that equation, we know that at this point, we know the y value is -1. We know the y value is -1, but we don't know what the x value is. Now we just reverse log to try get x. So we know that x will be equal to the base to the power of this, and that will actually just give us a half. So that means that this x value over here is a half, and we know the y value is -1. So if I just redraw this log graph, we know that it actually goes through that point, like we said, through there, but then it hugs the asymptote. It goes very close to this asymptote. So our answer that we're looking for now is this piece over here, but we're using x values. Sorry, now it's there. So our answer is inside here. So what we'll say is that x is an element going from the asymptote, which you never include an asymptote, up to a half, which I will include because they have included. Okay, now if you use set builder notation, you could say x is bigger than 0 but smaller than or equal to a half. This question says, if h is equal to f with a minus x in it. Okay, so that means that if f of x is 2 to the x, then h of x, which they said is f of minus x, then you're just going to plug a minus into the place of x. There we go. So that's the equation of h. Now this can be written in different ways if you wanted to. It says calculate the value of x for which this minus this is this. Okay, let's just go turn that into an equation. So we could say f of x is equation minus h of x, and we'll make that equal to 15 over 4. So we have 2 to the x minus 2 to the minus x. Okay, now what I would do here is I would take that down to the bottom, so it'll be 1 over, and then it becomes a positive. And then here you can use k method actually. There are other ways we can do this, but let's go with k method. So we could say k is equal to 2 to the x. The other way would have been to get a common denominator, blah, blah, blah. Okay, but then you probably would have switched over to k method anyways. So if k is equal to 2 to the x, then this is going to be k minus 1 over k equals to 15 over 4. Now we need to get a common denominator, which would be 4k. So that means this needs to be multiplied by 4k, top and bottom. This one needs to be multiplied by 4, and this one needs a k, top and bottom. And so here we end up with 4k squared minus 4 equals to 15k. We don't need the denominators anymore because in maths, when you have an equation and the denominators are the same, then you no longer need those denominators. Now it's just an easy case of solving this quadratic. I'm just going to use the quadratic formula. Obviously in an exam you would write out the formula, fill in the values, but just to save us time, I'm going to quickly just go calculate everything on my calculator. And so what you must find is that k is 4 or k is negative a quarter. Okay, now that's not the answer because they don't want k, they want x. So we know that we've got this now. So let's go do the first one. So if k is 4, then we're going to end up with And what did we say? Oh, we said k was 2 to the x. Yeah, shouldn't have erased that. Okay, so then we can say 2 to the x equals to 4. 2 to the x is equal to 2 to the 2, and so therefore x is 2. Okay, now if k is minus a quarter, which is this one now, then we say 2 to the x is equal to minus a quarter, but now this will have no solution. You can't, this expression here is an exponential graph, which is this one over here. And we said that that thing is always positive. It can't be a negative. There is no value for x that you could plug in here. You could, if you're in grade 12, well, everyone watching this is in grade 12 because it's a grade 12 kind of question. Even if you tried to use logs here, you're going to get an error. So this is just going to be a no solution. So then the only answer would be x is 2. Two friends, Kuda and Tabo, each want to invest 5,000 Rand for 4 years. Kuda invests his money in an account that pays simple interest, 8.3% per year. At the end, he will receive a bonus of 4% of whatever he has, like how much he has. Tabo invests his money at 8.1, but it's compounded monthly. Whose investment will yield a better return? Okay, so straight off the bat, I would assume, I think Tabo. Because compounding usually goes better. I mean, it always goes better. But I also know that they're gonna give Kuda a bit of a bonus. Okay. Anyways, I'm just busy trying to figure this out manually. But let's quickly go solve this. So let's go do Kuda. Okay. So Kuda, he's gonna use simple interest. So that's this formula. And so we're gonna say that he puts in 5,000 Rand. The interest rate is 8.3% per year, so we can just say that, and then that's going to be for 4 years. Okay, let's see what he gets, and then we'll add on the 4%. Okay, so that's going to be 6,660. Now he's going to get 4% of that, so 0.04 of that amount, and that means he will get a total of 6,926 Rand and 40 cents. Okay, now let's look at Tabo. Tabo is going to use compounding. Now he also starts with 5,000. His interest rate is going to be 8.1%, but it's compounded monthly, so we're going to say over 12. Now he's going to go for 4 years as well, so we say 4 times 12. Okay, curious to see how this plays out. Ooh, it's close. 6,905 Rand and 71 cents. So whose investment is the better return? Kuda. Usually compound would beat simple, but because they gave this little bonus at the end, it made a bit of a difference. And also this one's 8.3%, this is 8.1, although this one is compounded monthly. But so who gave the better investment? Kuda. Kuda investment is better.
9 years ago, a bank grants Mandy a loan of 525,000 Rand. The loan is repaid over 20 years, compounded monthly. Mandy's monthly repayments commenced exactly 1 month after the loan was granted. That's pretty normal. That's how it should be. Mandy decides to make monthly repayments of 6,000 Rand instead of 5,066. How many payments will she make to settle the loan? So, guys, if Mandy wanted to pay her loan off in 20 years, then she was told by the bank to pay 5,066 Rand. So that would have taken her 20 years, which is 20 times 12, which is 240 years. Okay, 240 years. Jeepers, Mandy. 240 months. That's how long Mandy would have taken to pay back her loan. Okay, but Mandy's feeling ambitious and brave, and she decides, I'm going to pay 6,000 Rand instead. Why not? I'm going to pay back more. Okay, there is a reason why you would do this in real life, because the more you can pay back, the faster you can pay it back, and the less interest the bank will be able to charge you. Okay, that's the reason she would have done this in real life. Now, We want to now work out how many payments does she now need to make to settle the loan. So we're going to go use the present value formula because this is a loan, and we typically use this formula with loans. Right. Now we know the loan amount was 525,000 Rand. We know that Mandy's going to pay 6,000 Rand. The interest rate, sorry, is 10%, which is the same as 0.1. You can write 10% if you want. I know a lot of you like to do it that way. And then we don't know how long this is going to take. So we're just going to leave it as minus n. Close the bracket over 0.1 over 12. Aha. Now you should know that whenever we end up with an exponent as the unknown, we're going to have to use logs. Sorry to tell you guys this, but we're going to have to use logs, okay? So what I would do next, now you can solve this in multiple different ways, but what I would personally do next is I would multiply this part up there, and then I would divide by 6,000. Okay, then I would divide by 6,000. And so what we would get after doing those steps is the following. 525,000 multiplied by 0.1 over 12 divided by 6,000 equals to 1 minus 1 plus 0.1 over 12 to the minus n. By the way, I have mentioned this on the online course, is that when you are dealing with financial maths where the question wants you to calculate the number of payments, you cannot round off at all. It is it changes your answer quite a lot. So don't round off at all. So what we can now do is I'm going to quickly take all of this stuff. Oh no, that's not good. I'm going to quickly rewrite everything over here. Now, we don't need these brackets anymore. These brackets. Those brackets were only there to keep the 6,000 away. But that 6,000 has now gone. So we can take those brackets down. Okay, so we can delete and delete or erase. What we can now do, or what I like to do in these moments is I mean, you can do this in multiple ways. You can take this one over to the left-hand side. So that's going to give us this. Notice that I'm not typing anything in on my calculator because I don't want to have to round off or store values on my calculator and all of that weird stuff. I just want to keep it simple. Okay. I'm just going to erase a whole bunch of stuff now. Right. Now, what we can now maybe do is we could maybe type this in on the calculator. I just want to see if the answer is nice. Like, does it have a whole bunch of decimals or is it nice? Let's just check. Okay, it's minus 13 over 48. Don't write the decimal form. Keep it as a fraction like that. It keeps it increases our accuracy. Okay, and then on this side, right, we can then get rid of the negatives because there's a negative on both sides. So we can just cross that out, cross out, cross out. And so now we can use logs. And so that would eventually give us n equals to log 1 plus 0.1 over 12, and then 13 over 48. And then you go ahead, you type that all in on your calculator, negative, and then that's a negative 157.40. So that means n is equal to 157.40. But they said how many payments? So you can't make 157.4 payments. You're going to pay the bank 158 times. And the last payment will just be a little bit less. But you are going to physically pay the bank 158 times. Okay? After making monthly payments of 6,000 Rand. So guys, remember that Mandy is a superhero. She was only supposed to pay about 5,000 Rand a month. Remember, guys, she walked into the bank and the bank told her, hello, Mandy, you only have to pay 5,066 Rand. And Mandy just smiles at them and she's like, make it 6,000. And so Mandy's been paying 6,000 for 9 years or whatever. Mandy's required money to pay for her daughter's university. She approaches the bank for another loan. So she goes to the bank. Listen to this, guys. She goes to the bank and she's like, "Hey, bank, I need a loan for my daughter. She's going to university." All of a sudden, the manager at the bank comes out of his office, or his or her office, and they say, "Hey, aren't you the Mandy that's been paying us more than you're supposed to?" I'll tell you what, Mandy, we don't need, I feel like I'm reading you guys a story here. I'm just trying to paint a picture for you guys. So the man at the bank tells Mandy, "You don't have to take out another loan. You've been so good to the bank. You've been paying more than you're supposed to. How about we make you a deal? All of the extra money that you've been paying for the last couple of years, why don't we pretend that that was an investment? Let's see how much that would have been worth up till now, and we will give you that amount." Okay? And that's what this question's sort of doing. But now be careful. This question's not talking about the full 20 years. They just said that Mandy's been paying her 6,000 Rand for the last 9 years. Okay? So for the last 9 years, Mandy was supposed to pay. How much was Mandy supposed to pay? Mandy was supposed to pay 5,066 Rand and 36 cents. 5,066 Rand and 36 cents. However, how much has Mandy been paying? Mandy has been paying, she's been paying 6,000 Rand. So how much extra has she been paying? Well, that would obviously be 6,000 minus 5,066.36, and that's equal to 9. So Mandy's been paying an extra 933 Rand and 64 cents. So the bank manager says, why don't we pretend that all of that money was an investment, and let's see what that amount of money would have been worth. Okay. So what we can do is we can see what is the future value that all of these 933 Rands would have been from the beginning up till the 9-year period. How much money would that have grown to by now? The bank manager says, we will give you whatever that is. Okay, so we're going to use the future value formula. Okay, so we know that the monthly repayment is 933 and 64. And the interest rates, we will assume that it's the same as the loan. They don't really mention anything there. So that's just going to be 10% monthly. Okay. And that's only for 9 years. She's been doing this for 9 years. That's 9 times 12, like that. And so we can go calculate this now. And that means that that amount of money would have accumulated to 162,503 Rand and 51 cents.
Determine f with a line x, which is the first derivative, using first principles. Okay, so what I always tell learners to do is let's quickly work out the first derivative just using the FOST method. So we know that this will become 0, and then this will just become minus 7. So this is the answer that we will get at the end. If we don't, then you are guaranteed to have made a little mistake along the way. So we know that to find the first derivative using first principles, we have to use this formula, which is f of x plus h minus f of x over h. Okay, now remember that f of x plus h just means that you take this expression and you replace the x with x plus h. Okay, and then, okay, so let's go fill in the formula now. Here I was just showing you how it works. Okay, so f of x plus h is that. Then we say minus f of x. Now put this one in a bracket. So that's going to be 4 minus 7x over h. Okay, and then remember that you have to keep writing this limit as h goes to 0 down. Okay, so 4 minus 7x minus 7h minus 4 plus 7x over h. Now remember, as I always say, at this next step, we're going to simplify. And everything that doesn't have h should cancel. If it doesn't, you have made a mistake, and that mistake is usually over here by not using a bracket, so that this would be a negative. so that it can't then cancel. So if you look here, this 4 cancels with that minus 4. This minus 7x cancels with that plus 7x. And so what we're left with now is minus 7h over h. Now normally we would take out a common factor at the top, but there is only one term, so these h's can cancel. And so what we have now is just minus 7. And so technically we're supposed to let h become 0 now, but there is no h. And so the answer is just going to be minus 7. And that is exactly what we said earlier. Okay, yeah, they want us to determine dy by dx. If they ask us to determine dy by dx, or f of x like that, or dx like that, it all means the same thing. It all means first derivative. Okay, so to be able to take the first derivative of this, we need to fix it up a little bit first. Specifically, we can't have this root like that. So we rewrite it in a different way. We know that this can be the inside number over the outside number. Now, if there's no number here, then it's a standard 2. And there we go. Now we can take the derivative. So we say dy by dx. Okay, so we take the 8 and we multiply it by 4. Then you subtract 1 from the exponent. Then you take the 3 over 2, multiply it in the front here, which is just going to be 1.5. Then you subtract 1 from here, which is just going to be a half. And there we go.
So what this one says is we are given this expression over here, and they ask us to determine the derivative of y with respect to x. Okay, so this is just a normal question, dy by dx. So we're just going to take the normal derivative over here. So we're going to go dy by dx. And so let's just say dy over dx equals. And now we're just going to take this number 2 here, and we're going to multiply it in the front like we normally do for derivatives. Hey, guys? So it's going to become 2ax. And then whenever we have a number like a, or it could be the number 5, the number 3, any type of number, when we take the derivative of that, it's just going to become, oh, wait, let me just see. Yeah, the derivative, it literally just falls away. So that's just going to become 2ax, and that is the final answer. Because as soon as you have a number like 3 or whatever, it just falls away when you take the first derivative. This next one's a little bit weird, okay? So what it actually means, it's very interesting. It means that we're still going to take the derivative with the y. So what that means is you must get the y by itself. You must always get this letter by itself. Sometimes they might have a dx at the top. Then what you would do is you would get x by itself first. But with this question, they've got the dy at the top. So you must have the y value by itself. And that's what we've got over here. But then what's very weird now is that you are going to look at the variable a. You're going to look at the variable a, and you're going to treat the x's as constants. So you're going to treat the x's as numbers now. So that's what makes things a little bit interesting. Okay, so I'm going to say dy by dA equals. Okay, so now we're going to pretend that this is a number, and then this is our variable. So the a is the variable. So if you just have the a as the variable, then that will just disappear, and you're just going to be left with x squared. Okay, then you're going to say plus. Now, if you take the derivative of a, it's almost like taking the derivative of x. What would that normally become? Well, that would just become a 1. The curve with a certain equation passes through the point A. Determine the equation of the line, which is perpendicular to the tangent at A. Now, for some of us, when we read this, we're going to be like, oh my gosh, like, what does this even mean? I know, right? It's super weird. So let me try to draw a picture for us and try to make it a bit easier to understand. So if we had a normal graph, okay, let's draw a normal graph. And I'm not going to draw an accurate graph. I'm just going to make a random graph. Let's draw a random graph like that. And let's say this point over here is the point A. Let's say that's point A. Or no, that wouldn't make sense because they said x is 2. So let's say A is over here. So we put 2 and B. Right. Now they said, determine the equation of the line which is perpendicular to the tangent. Okay, so let's go draw a tangent first. So a tangent would look something like this. A tangent is a line that touches at that point in one place. So it would be something like that. Okay, so that's the tangent, right? Let's label that as tangent. Okay, then they said they want the equation of the line that is perpendicular to the tangent. Oh my word. So it must be perpendicular to the tangent. So then I'm going to go like that. Crazy, hey guys? And so then we know that these are at 90 degrees. All right. So now we need to know, our goal for this question, guys, is to find the equation of this green one. So this green one is y equals to mx plus c. So that's crazy. 4 marks. I would imagine it could have been worth a little bit more because we've got to do quite a few things now. So let's make a few notes about what we should remember about tangents, perpendicular lines. What does a tangent and a graph have in common? So a few important things I would want you guys to remember is the following. Number one, the gradient of the tangent is the same as the gradient of the graph. Okay, so the gradient of the tangent is the same as the gradient of the graph. Now, which one is the graph? I'm talking about this one. That one is the graph, right? Your teacher would have told you this before, that the gradient of a tangent is the same as the gradient of a graph at this point, at that point over there. Number two, we should understand that the gradient of the tangent, or no, sorry. If two lines are perpendicular, then you guys can remember what that means. If two lines are perpendicular, then it means that their gradients multiplied together should always give you -1. These are the two important things that we need to know if we want to be able to solve this question. First derivative means gradient of the graph. So these two things are the same. Okay, so the gradient of the tangent is the same as the gradient of the graph. And to find the gradient of, oh, that's probably something I should have added. The gradient of the graph, we always find that using the first derivative. Remember, guys, that the first derivative stands for the gradient. Okay, so how are we going to do this? So what we're going to go do, I think what we can do first is we can go find the gradient of the graph. Let's go find the gradient of the graph. And how do we do that? Well, that's where calculus helps us. So we can use the first derivative. So let's first go write this down. Now, before we can take the first derivative, we first need to rearrange this equation and make it a little bit more user-friendly. So what I'm going to do is I'm going to bring that x to the top. So it's going to look like this. There we go. Now we can take the first derivative. Now, guys, they might penalize you in the test if you forget the following thing that I'm about to do, but they probably won't. Maybe they'll -1 mark. So because they're using a y over here, when you take the first derivative, please don't do this. Don't do this with a line like that. That's not what you want to do. You can only put a line like that if they use f of x, if they use f of x. But if they use a y, like this, then you have to use the correct notation. But hey, if you're sitting in a test and you can't remember, just do whatever. They'll probably -1 mark, honestly. Okay, so you can just go dy over dx. Now we're taking the first derivative, so that's going to be equal to 1. And then this -1 is going to multiply to the front, so that will become -12 x to the power of -2. See, I'm just taking the first derivative. Now, we know that this first derivative, this thing over here, stands for the gradient. So we can find the gradient of the graph by just plugging in the x value of that point. Remember, the x value of that point is a 2. So I can go and plug in a 2 now. All right. Dx. Okay, so now what I'm going to go and do is I'm going to plug in the x value of that point because I want to know what is the gradient of that point. And so it's going to be 1 minus 12. And then I'm going to plug in a 2 over here to the power of minus 2. And then you can just go ahead and type it in on your calculator. And let's see what that gives us. And so that's going to give us negative 2. So what that now means is that the gradient of the graph is equal to negative 2, right? The gradient of the graph is equal to negative 2. So let's say that here. Therefore, the gradient of the graph is equal to negative 2. So then what we can see is that the gradient of the graph is always the same as the gradient of the tangent. So now we have the tangent. So the gradient of the tangent is also negative 2. So that's quite nice. Now, because we know the gradient of the tangent, we will now be able to get the gradient of the perpendicular line. Because if there's now, because we know that the if two lines are perpendicular, when you multiply their gradients, you will get negative 1. Okay, so let's quickly have a look here. All right, so the gradient of the, so now what we're going to work out is the gradient of the perpendicular line. Okay, now the way that we do that is we know that the gradient of the tangent multiplied by the gradient of the perpendicular line should be equal to negative 1. That is just a mathematical concept that we've learned since grade 10, actually, even grade 9. Now, so what we can do is we can say minus 2 multiplied by the gradient of the perpendicular line equals to negative 1. What you would find is that the perpendicular gradient should be a half. So then what we can do is we can say y equals to mx plus c, and we can then say y equals to a half x plus c. Right, so now guys, to find the value of c, we need to find a point on the perpendicular line. Now that point is going to be this point over here, but the problem is that we don't have the y value. But that's not a problem because we can just plug the x value. We can just plug the x value into the original equation, which we have over here. So we can just plug in the x value of 2. And if you had to go work that out, you're going to find out that the y value is going to be equal to 8. So this y value over here is 8. All right. And so now we have the y value as 8. And so now we can substitute the point 2 and 8 into the equation, this equation over here. And we can go 8 equals to a half times 2 plus c. And we should find out that c is equal to 7. And so the final answer would be y equals to a half x plus 7. So this one says it's sort of about some insect that's busy crawling around on a wall. The story about the insect's not that important. The insect started crawling on the wall. The path the insect crawled can be given by this equation. Okay. Then it says h is the height and t is the time. All right. So I'm going to draw a little picture for you guys. It's a very basic picture. We've got a wall. So here's our wall. And we've got some little insect. We've got some insect that is busy crawling around. And the equation that we can use is given to us over here. And all that we really need to understand is that, oh, don't do that, Kevin. All that we must understand is that if I write this equation over here, we should understand that the y value is the height. And then the t is almost like the x values. So, I mean, the t is the x value, but it represents time. Okay, that's the main thing that you need to understand. And they can do this for anything. The y values can be the height of water in a tank, and the x values can be the time. Or the y values can be the height of a soccer ball, and the x values can be the time or whatever. So we're just using calculus in a real world scenario. In question 8.1, it says, at what height above the floor did the insect start to crawl? So guys, when it says it started, we know that when something starts, the time will always be 0. So all that I do is I take this equation and I plug in 0 in the place of time, because that's how anything starts. You always start at 0 time. Then I can go ahead and I can just plug all of this stuff onto my calculator. And we should get, oh, that's not right, 36 centimeters, 36 centimeters. So that was the original height that the insect started to crawl. Okay, then it says, how many times did the insect reach the floor? So some of you might read this and you're like, jeepers, how the hell are we supposed to know this? Well, guys, it's actually quite easy. Remember that when the insect hits the floor, okay, when the insect hits the floor, maybe it's a sad insect now because it's hitting the floor, then we know that the height when it hits the floor will be 0. You see? This insect actually looks like a carrot. But anyways, so we make the height equal to 0, because then we know that the insect is hitting the floor. So what I'm going to then do is I'm going to go to the original equation, and I'm going to make the height equal to 0. So I'm going to go 0 equals, now I don't know what the time is, so I just leave it as t. There we go, guys. Now this is our equation that we need to solve. Now hold up, a lot of you might be tempted to multiply the two brackets together. In fact, some of you might be doing that right now. Now, that's not incorrect, but you're going in a cycle, because what's going to happen is you're going to multiply, and then you're going to get to a certain part, and then you're going to be like, oh yes, now I'm going to factorize. And then you're going to get back to this exact same step. So remember, when you're trying to solve an equation, brackets are good. We want the brackets, because when you have brackets, you can easily solve. Because what I can now do is I can say that this part must be equal to 0, or this part must be equal to 0. Right. Now, if I solve this one, I would end up with t equals to 6. So what that means is that at 6 minutes, the insect will reach the ground. So that's at 6 minutes. And then you need to try solve this one, either using factorizing, or you can use the quadratic formula. But I'm going to spoil the fun for you, and I'm going to tell you right now that if you try to solve this equation over here, you are going to get an error on your calculator. What that means is that there is no solution for this part. No solution. So that means the insect only reaches the ground at 6 minutes. So it only touches the ground once. There was only one answer. All right. This question says, determine the maximum height that the insect reached above the floor. Now, guys, remember that this little carrot insect, this insect can follow any specific path that it wants. It can go like this. It can go like this. It can go backwards again. It can go up. It can go down. But technically, yeah, it wouldn't be a function if it did that. But let's say the carrot does this. The insect, sorry. Let's say it does something like this. Now, if you wanted to work out the maximum height of this insect, you would need to be able to find, it's going to be a cubic. Sorry, guys, this is a cubic equation. If you multiply it out, you'd realize it's cubic, so it's going to be something like that. That's what a cubic looks like. So if you want to find the maximum height, you would have to go and find this position over here, which is the turning point. Now, remember, if you want to find a turning point, how do we do that? Well, at the turning point, can you see that the gradient of the graph is 0? So that's something important. At a turning point, the gradient of the graph must be 0. Okay? At the turning point, the gradient of the graph must be 0. So how do we find the gradient of the graph? Well, remember that we can use calculus. We can take the first derivative. But in order for us to be able to take the first derivative, we first need to multiply this out and make it look a little bit better. Okay, so if we go multiply it out now, you're going to get minus 2t cubed plus 3t squared minus 6t. So I'm just busy multiplying out now. Easy stuff for you guys. Okay, I'm just going to switch my video off quickly, and just in case it's in the way, that's a 36. Then I'm just going to simplify a little bit. There we go. Now I can go and take the, I don't know why I've put that as a 0. Oh, that was from earlier. I remember. Good. Now I can go take the first derivative, and that's going to give me minus 6t squared plus 30t minus 24. So we took the first derivative over here, and now we are going to make that equal to 0. So let me quickly move it up for us a bit. Okay, and so now we're going to make the first derivative equal to 0. Right, and then you can go solve, guys. Now you can solve this equation however you want. If you would like to use the quadratic formula, that's fine. If you want to divide by minus 6 and then factorize, you can do this in many ways. To save all of us time, I'm just going to quickly get the answers on my calculator. Yeah, this is something that you guys know off by heart by now. So I'm just going to go get the answers quickly. All right. So what we'll find out is that the answer is at 4 or 1. T equals to 4 or T equals to 1. So guys, what we now need to understand is that if this insect is going like this and like this, what it might also be going like this. It might be going down first and then up. So what we have found now is that the turning points are at 4 minutes and 1 minute. But the problem is we don't know which one is the maximum height and which one is the minimum height. You see, it might be maybe the 4 minutes is the maximum height and the 1 minute is the minimum height, or it might even be the other way around. So how do we try to figure out what the correct one is? Simple. All we do is we take those two x answers and we go plug it into the original equation. And it doesn't matter if you do it into that equation or if you want to do it into this one after we multiply it out. It doesn't matter at all. And we go see which one is going to give us the best y value. Not the best y value, the highest y value. Okay, so that's what we'll go and do. And so we can go h of 4 equals to 4 minus 6. I'm just busy plugging in the 4 into the original equation. And if you had to go work this out, I'm just going to go through it quickly, guys. That'll give us 52 centimeters. That might be the answer, but we need to check the other one as well. So I need to go plug in the 1 as well. And that's going to give us 1 minus 6 minus 2 times 1 squared plus 3 times 1 minus 6. And so that's going to give us 25. Aha. So they said find the maximum height. And so the maximum height would be the 52 centimeters. That must be the maximum height. Given f of x equals to 3x to the 3, solve. Where is f of x equal to its first derivative? Ooh, okay, that's interesting. So f of x is just 3x3. Its first derivative is 9x squared. So we're going to make those two things equal now. So we're going to say 3x3 equals to 9x squared. Now we just need to solve. So I'm going to take everything, and please, please, please don't divide by x squares. You never want to divide by x like that. You always want to rather take it to the other side, then take out a common factor. There we go. Now we can say 3x squared equals to 0, or x minus 3 is equal to 0. So here, if you solve this, you would actually just eventually end up with 0. Technically, you'd get 0 twice because there's two answers here. And then here, you would end up with 3. Perfect. The graphs of f prime, and f double prime all pass through the point 0, 0. For which of the graphs will 0, 0 be a stationary point?
Okay, well, I'm going to quickly draw these graphs for you. They're very quick and easy. This is just a standard cubic graph. The 3 in the front doesn't really do anything to the shape. So if you ever get a cubic graph that just has an x3, then all it does is it just does this. It's got no real, or it actually flattens out over here. Sorry, it flattens out there, then goes up again. So at the 0, 0, it flattens and then goes up. Okay, now, so that's that graph. Then the first derivative graph, that's just a parabola, with the x squared. The 9 in the front doesn't really do, it doesn't move it up, doesn't move it down, doesn't move it left, doesn't move it right. So that's just going to go like that. So let's actually just highlight this for ourselves. And then if we had to go take the second derivative, that'll be 18x. That is actually just a straight line, y equals to mx plus c. It just doesn't have the plus c. What that means is that it goes straight through the point 0, 0. But they told us that. They said all 3 of them do that. So this graph is going to go something like that. Okay, so let's do this one in blue. Okay, so they said for which graphs will 0, 0 be a stationary point? A stationary point is where the graph becomes flat, like that. So we can see on the green one, it becomes flat over there. And we can see on the yellow one, it also became flat over there. So we could say here, for the graph of f and the graph of f prime. For the blue one, it's definitely not flat. Okay, now it says, explain the difference in the stationary points referred to in question 9.2.1. Okay, so for the green one, that is called a turning point because you can see that it's turning, right? Whereas for the yellow one, it's not actually a turning point. Remember, in grade 12, we get 3 types of stationary points. So let's make some notes here. Okay, so we get a normal one like that, which is called a minimum, and that's also called a turning point. Then you get this one, which is called a maximum, and it's also a turning point. You can see it turns, you can see it turns. But then you get one like this. Now here it's still flat, so we still call it stationary, but it's not a turning point. Okay? And so we could say that f is not a turning point, whereas f prime is a turning point. Or you could say has a turning point. Does not have a turning point and has a turning point. And by the way, when you get one that looks like this, then that is automatically going to be an inflection point. So we could even add here, f is not a turning point. We should actually add the coordinates at 0, 0, and then f is a turning point at 0, 0. For this one, we could say the point 0, 0 is an inflection point. I'm not saying that it's only an inflection point when you have this. You can get other types of inflection points, but in these 3 categories, whenever you end up with category 3, then that place where it's stationary is a inflection point. I wouldn't worry too much if this is a bit confusing for you. In all my years of teaching, which is now, it's a good couple of years, I've never seen them test learners like that, okay, where you have to know this kind of stuff in such detail. So don't stress too much about this. It's a bit of a weird question, to be honest. Okay, I'm going to erase this now just so we can see the next question nicely. Okay, so the next question says, determine the vertical distance between the graphs of f prime and f at x equals to 1. Very easy. So they want to know the vertical distance between the blue and the yellow graph, the blue and the green graph, between the blue and the green graph when x is 1. Now, don't worry too much about the drawing because my drawing might not be perfect. Maybe the blue is above the green or the green is above the blue. Doesn't matter because all we do is we use the 2 equations now. And if we know that this one is that, now x is 1. So let's go plug x as 1. That'll give us 9. Then for the other one, x is also going to be 1, but we're going to plug it into here now. And that'll be 18. So because this one is higher, or it's a bigger value, it means it's higher up, and this one's lower down. So what is the vertical distance? Well, you can imagine that on this graph, x is 1 and y is 9. Maybe that'll be there. And then on this graph, x is 1, but y is 18. So what would that vertical distance be? Well, you would say 18 minus 9, which is 9. Okay, this last one says, for which values is f of x minus that graph smaller than 0? Okay, so we can say 3x cubed minus the first derivative graph, which is that one. Okay, now here you can take out a common factor of 3x squared, and then you'd be left with x take away 3. Now, they want to know, where is this expression multiply by this expression negative, smaller than 0? What you must understand is that this expression here is always positive. Well, positive or 0, okay? So we don't want x to be 0, because then this whole expression would be equal to 0. But for any other x value, can we agree that this expression will always be positive? No matter what x value you plug in there, that whole thing will be positive. Even if you plug a negative x value in here, when you square it, it becomes a positive. Okay, so we could say that 3x squared is always bigger than 0 for any x value, but x just mustn't be equal to 0. Okay, so any other x value besides 0, that thing will always be positive. So if this thing is always positive, then what must this expression be, so that when you multiply these two expressions, you have something that is smaller than 0, which means negative? Well, we know that a positive multiplied with a negative gives you a negative. So we would like that expression to be negative, smaller than 0. So we could say x, so we could then take the 3 over, and we could say x is then smaller than 3. So the final answer then would be x is smaller than 3, but we must just remember that x is not allowed to be equal to 0. School library is open from Monday to Thursday. Anna and Ben both studied in the school library one day this week. Okay, so Anna and Ben both studied in the school library one day this week. Okay, if the chance of studying any day in the week is equally likely, calculate the probability that Anna and Ben studied on the same day or consecutive days. Okay, so what I think we can do here is I'm thinking we could just do like a manual table. So Monday, Tuesday, Wednesday, Thursday, Anna, and then Ben. Now let's go look at all possibilities. Okay, so we could have both of them study on Monday. So that's 1. They could both study on a Tuesday. That's 2. They could both study on a Wednesday. That's 3. They could both study on a Thursday. That's 4. So far we have 4 possibilities. We could also have Anna study on a Monday, and then Ben could study on either Tuesday, Wednesday, or Thursday. So that's 1 possibility over there. That's 2 possibilities. That's 3 possibilities. Okay, so now we're up to 7. Then we could have Anna study on a Tuesday, and once again Ben could go there, there, and there. We've already looked at Tuesday. That's what we did first. So there we've got another 1 possibility, or it could go like that. That's 2, or like that. That's 3. So now we're up to 10. We could also have Anna study on a Wednesday, and then Ben would be there, there, or there. So that's now 13 possibilities. Or we could have Anna study on a Thursday, and then Ben could be there, there, and there. So now we're up to 16 possibilities. And that pretty much covers every scenario, because we could put like Ben there and Anna there, but we've done that possibility already. We could go there and there. So it looks like there's 16 possibilities. Okay, so out of 16 different scenarios, how many times can they study on the same day? Well, there's 1, or it could be Tuesday, or it could be Wednesday, or it could be Thursday. So that's 4 out of 16. So that's a quarter for the first one. Okay, now consecutive days. The word consecutive means after each other. So what that means is, like, you could have Anna on a Monday and then Tuesday is Ben. So that's 1 possibility. You could have you could have Ben on a Monday and then Anna on a Tuesday. That's another one. You could go there, Anna on a Tuesday. Oh no, we've done that one. You could have you could have Anna on a Tuesday, Ben on a Wednesday, or Ben on a Tuesday, Anna on a Wednesday. So that's another 2 possibilities. That's 4. Or you could have Anna on a Wednesday, Ben on a Thursday, or Ben on a Wednesday, and on a Thursday. So that's another 2 possibilities. So that's 6. So that's going to be 6 out of a total of 16. And if you simplify that, you would get 3 out of 8. Events A and B are independent. Right there is something very important. When 2 events are independent, then you are allowed to say the following. That is a formula when 2 events are independent. Okay, so it says represent the given information on a Venn diagram, indicate the Venn diagram probabilities. Okay, so on a Venn diagram, we know that they will intersect, because if we know that the probability of A and B is 0, then we call that mutually exclusive. But then on your Venn diagram, it would look like that. Okay, so then Kevin, how do we know that they intersect? Well, they just told us that they are independent, so that means that the probability of A and B is these 2 multiplied together, and that won't give us 0. So there is definitely an intersection in the middle. Okay, now what a lot of learners do wrong is they say, oh, probability of A is 0.4, and then they go put 0.4 here. Not correct. When they say probability of A is 0.4, they are talking about the entire probability of A, and the same with B. So, what I would say we should do first is they told us that probability of A and B, because they are independent, we can multiply them, which is going to be 0.4 multiplied by 0.25, which is going to be 0.1. So that means this part is 0.1. That then means this part is 0.3, so that A is 0.4 in total. And then this would be 0.15, so that B is 0.25 in total. Now, we can add these 3 things together, and that would give us 0.55. That's called A or B. We know that all probability, however, should add up to 1. So to work out what's on the outside here, we could say 1 minus 0.55, and that'll be 0.45. So we can put that on the outside of here. So it says represent the information on a Venn diagram. We've done that. Determine the probability of A or not B. So A or not B. Okay. So if we go look at probability of A, well, that would be this one and this one. Okay, so let's actually highlight that. And then it says not B. So not B. So if you scratch out B, not B would be here and here. Okay. So not B is going to be here and here. Now, take that away now. Now, you're going to, all the places where you see a tick, you're going to add that together. But because this one has 2 ticks, you're not going to add them both. You're just going to add one of them. There's a tick here and there's a tick here. So we're going to say 0.3 plus 0.1 plus 0.45. And that'll give you 0.85. If the question had an and over there, then it has to be yellow and green. So then the only answer would be, just hold on, then your only answer would actually be this part over here, because there we can see that both the A and not B was satisfied over here. But because they're saying or, it just means that it has to be in this category, or it can be in this category for us to be allowed to count it. Okay, so we get 0.85. Motors Incorporated manufacture cars with 5 different body styles, okay, 4 different interiors, and 6 different exteriors. Okay, the interior color of the car must not be the same as the exterior. Okay, so for example, you cannot have a blue interior with a blue exterior. Okay, or you can't have a red interior with a red exterior. Motors Incorporated wants to display one of each possible variations of its cars in their showroom. The showroom has a floor space of 500 square meters, and each car needs 5 square meters. Could the display be possible? Okay, so for example, there's 5 different body styles. So let's call them A, B, C, D, and E. So you could, for example, buy a car that has a D body style, a gray interior, and a red exterior, for example. That is one type of car. They want to know how many, pretty much they want to know how many different car variations could you get. So, I'm going to do, so we know that in grade 12 probability, like if you go out for dinner and you have starter, a main, and a dessert, we know that we can normally just multiply all of the options. So for your body styles, there's 5. For your interior colors, 1, 2, 3, 4, there's 4. I know that for some of them the colors can't be the same, but we'll take care of that now, don't you worry. And then for the exterior colors, there's 1, 2, 3, 4, 5, 6. So this is the total number of cars there could be if we didn't worry about what they said over here. But we will worry about that now. I just want to quickly work out this total so long. So 5 times 4 times 6 is 120 cars. Okay, but now you're not allowed to have, so we're going to say these cars are not allowed. So let's say we're choosing all the cars now that are not allowed. So that would be, you can choose from 5 different body styles. Now, if you chose, which are the matching colors? There's blue, and there is black, no, and red. Okay, so let's choose the blues quickly. Let's say blue, the blue interior with a blue exterior. Well, how would you choose that? Well, there's 5 different body styles, and then if you're only allowed to choose blue, that's 1, and if you're only allowed to choose blue, that's 1. Okay, now what about the red? And that's going to equal 5, by the way. What about a red interior, exterior? Well, that would be the same. 5 different body styles, 1 red option, and 1 red. So that's 5 different cars. Okay, so we're going to take 120, which is the total number of variations if we didn't care about the interior and exterior being the same. Then we're going to minus the cars that are blue interior, blue exterior, and we're going to minus the cars that are red interior, red exterior, and that's 110. So there's 110 cars. Each car needs 5 square meters. That's going to give you 550 meters squared. That won't work because they only have a space of 500 squares. So we'll say, therefore, display not possible.